Let's begin. I don't think it's on. Let's begin with our first company. No? Let's begin with our first company this afternoon. Please welcome Ms. Megan Lacey, Chief Design Officer and Co-Founder, and Mr. Corbin Hennon, CEO and Co-Founder from the Lumineye Incorporated. The topic of their demonstration is Man-Portable Wall-Penetrating Radar. The company will have 20 minutes to demonstrate their technology, followed by a 10-minute Q&A session. And when you are ready to begin, we will start the clock.
Thank you. My mic. Okay, there we go. Awesome. Hi, I'm Megan Lacey, and I'm one of the co-founders and chief design officer of Lumineye, where our mission is helping soldiers and first responders save lives. So I'm sure a lot of you in this room have been in this situation before. You're about to enter a blind breach, and you have no idea what danger lies on the other side. Well, after hearing the stories of over 300 soldiers, operators, commanders, and first responders, we know that not only is this a regular occurrence, it's very often a matter of life and death, which is why we're working so hard to provide soldiers and first responders with a tactical wall-penetrating radar to help them identify these people and threats through walls. So there are existing through-wall sensors out there, but they're not meeting tactical needs of the users. This device weighs over 30 pounds. For a tactical use case where you might have to travel miles to your destination, you can't carry that weight. And once you're at the scene, you need someone else to protect you while you're using the device, so you're a liability for your team. We had a special operations operator tell us that they'd rather eat bullets than carry the current devices. We've heard this over and over again. Ounces equals pounds, pounds equals pain. And we don't want to add any more weight to those packs because they're already heavy enough. Through-wall sensors also have to be intuitive and easy to read. This device requires a lot of training, and even when you're trained on it, it requires a lot of mental capacity in a very stressful moment to identify what's going on. A former FBI HRT officer told us he needs something that's idiot-proof. He doesn't have time to think in these high-stress environments. And that's why we're building a portable, compact through-wall sensor. Here's two of our user interfaces. We have 1D and 2D tracking with our device. We also have it up here. So it's much more compact. It weighs about 1.5 pounds. So who are we, and why are we building this? As I mentioned, I'm Megan. I'm a mechanical engineer, and I have a background in user-centered design from the Stanford D School. My co-founder, Corbin, over there, is a self-taught radar engineer, and he's also helped his parents build their company from a garage to a multi-million-dollar company just in the last few years. He also has NASA imaging research experience using infrared and radar to look through Titan's thick haze. And he also has a personal story that started this whole company. He actually lost a friend in a blind breach. And so we didn't want anyone else to have to go through that experience that him and his family friends went through when they lost that friend. And then Rob is our third co-founder. He has a bachelor's and master's in computer science, and he has years of experience doing signal analysis software. We also have Anthony and Jordan on our team, a software engineer and materials scientist. And then Lainey Lewis, who has over 20 years of DoD contracting experience. So we actually originally came through the Hacking for Defense program in January 2017. For those of you that aren't familiar with Hacking for Defense, it's a program that brings student teams together with the Department of Defense and IC agencies to solve real national security problems. So we were partnered with SOCOM during that, and they wanted to identify humans via radio frequencies. We learned very quickly they basically wanted to find out what's on the other side of the wall and as much information as they could. And that this also wasn't a problem, this was also a problem other first responders and soldiers were facing. Other soldiers, law enforcement, firefighters, and search and rescue all need to see through barriers and walls. We were so passionate about solving this problem that we quit our day jobs, we stopped going to school, and we bootstrapped this company for 2 years, working odd jobs and funding prototypes via pitch competitions locally. The X-Tech Search funding that we got 6 months ago was actually the first significant funding that our company ever received. And we've been able to make a ton of progress since then because of that funding. In June, we started in the Y Combinator Startup Accelerator program. For those of you that aren't familiar, it's actually the original Startup Accelerator, and they've funded companies including Airbnb, Dropbox, and now General Motors' autonomous vehicle section, Cruise. From there, we deployed our first units in July. We started 2 law enforcement pilots. Then in August, we started 2 more, and we got our first SBIR through the Air Force. In September, we were selected for our second SBIR, started our 5th law enforcement pilot, and were part of the Thunderstorm 19.4 through-wall sensing test and demo event. So we actually applied to X-Tech Search 1.0. And so 14 months ago, we were phase 2 finalists. We showed up there with a cardboard prototype. Needless to say, we did not make it to phase 3 the first time, but we got back to work, and we came back with a real working device in March for phase 2 and phase 3 demo. This device detected motion up to 22 feet away and did 1D detection, meaning it could tell how far away someone was from the wall. Now, we have still moving and breathing person detection. We have 1D and 2D detection and tracking, and then we also have increased our max range by more than 100%. We also have 10 units in the field, breaths per minute identification, remote viewing, multi-person detection, as well as wall detection. So what's next? So with the Air Force SBIR, we plan to focus on pose detection and skeletal tracking. This will help identify what the person's doing through the wall, and then also differentiate between adults and children. We'll also plan to ruggedize our device with this SBIR and go to full-scale deployment. With the Army SBIR, we're focused on hands-free device. We know that soldiers want to have their hands on their weapons at all times so that they can protect themselves. To do this, we'll be working on basic motion compensation and non-visual user interfaces for stealth missions. And then with the X-Tech Search funding, we'll be improving our 2D tracking, which you'll see a demo of today, and we'll also do some electrical consolidation that we can literally start on Thursday. We just need the funding to do it. So basically, this device can get down to this thick, just with some simple consolidation. We'll also be working on multi-person detection and mapping. So if you want to learn more about mapping, we can talk more about what I mean by that offline. Our transition plan is that we already have a direct to phase 3 capability on a sole source contract through our existing SBIR. Our team member, Lainey Lewis, already has a GSA schedule that we can sell through now. And we have a manufacturing partner that can scale up to tens of thousands of units, is ITAR compliant, and focuses on military-grade devices now. So with that, I'd like to show you our 1D and 2D demos. So we have our devices back here. We're going to be using this wall, bookshelves, but wall, to show the demo. And first, we'll start with 1D. So you can see there's a, getting too close. Sorry. You can see that there's a device back there against the wall, and we'll have Anthony here on our team walking back and forth. Yeah, so basically this first demo will be that it'll be a 1D tracker, so showing how far away he is from the device. We can do motion detection, still person detection, and breathing detection. So we'll be showing all of those things. All right, looks like we're ready to go. So Anthony, if you want to start walking. So that icon in the middle is him. It represents that the running man represents that he's walking around. So if he stops walking, then you'll see that there's a still person detection. So there's the still person detection icon and then breathing icon. So if you want to move around again, you can get motion detection. And then if you want to slow down for breathing detection again. So still person detection, and then breathing detection at 8.4 feet. Okay, so that's 1D. Now we'll show you 2D. So the way that we do 2D is a little bit different than existing devices out there. 2D is actually it's a complex problem because you need the antennas to be spaced further apart. And so in order to keep our device very small, we actually use multiple devices to get 2D tracking. So we have Jordan back there with the second device and Rob up here with the first device, and they're setting those up right now. Does anyone while they're setting up, I'm happy to answer any questions about the setup. Nope. So with the 2D tracking, you'll be able to see both the direction, how far away they are, and then also the direction. Yeah. And we actually developed this in the last, so this was our #1 requested feature from our law enforcement pilots, and we developed it within the last month. So we made it our #1 priority because every single law enforcement department we were working with and all the soldiers we were working with wanted this functionality. All right, so it looks like we're ready for Anthony to go again. So A is the device that's further away, and B is the device that's closer to us. So you'll see it's picking him up, and then he might be a bit out of range if you want to stay close. We made the range a little bit shorter for the purposes of the demo so that it wouldn't pick up people in the hallway. All right, Anthony, if you want to stop and do some breathing detection. So still person and then breathing detection. Okay, you can keep going now. Yeah, so we'll do one more breathing detection. If you want to stop. Yep, and so that's breathing detection. So that's our 2D demo. And with that, we'd like to open it up to Q&A. Mm-hmm.
Is it millimeter wave?
It's ultra-wideband.
It's ultra-wide.
Yeah, so it's between the Wi-Fi bands.
Okay.
Yeah.
Yeah, so your Wi-Fi is at 2.4 and 5 gigahertz, and we're right in between 3.1 to 4.8 gigahertz.
So with the breathing detection, you can infer then if someone's sleeping or if they're,
Yeah.
concerned about something.
Yes.
Yeah.
Right?
We're also working on our heart rate detection,
Right.
which is particularly important for our search and rescue and a number of other users.
Right.
So what enabled you to get to that swap versus the picture you showed us is 30 degrees? What innovation did you make that allowed you to reduce the size such and weight?
Oh, yeah. So a lot of what we do is in the software signal analysis, and so a lot of it was just taking more time to write those algorithms.
Processing.
Yeah.
Yeah, and a big part for 2D and 3D tracking is the separation between the antennas, because that's how you get your angular resolution.
Yeah.
And so, we tried to build a 2D tracker right off the bat, test with users, because we knew lightweight. We got it under 5 pounds, and they're like, still not going to fit in my bag, and I still don't want to carry that around.
Yeah.
So it was like, okay, if that's just like, can't do anything about that, well, what can we do with a single device? Like, how much information can we provide with that? And that's getting to the breathing and the heart rate tracking. And then using multiple devices networked together, we can actually get much better angular resolution than even the ones that fold out, spread out, and everything else.
For the 2D setup, how have you idiot-proofed that to make sure that the team that's getting ready to be on the breach
Yeah.
is within min or max within tolerance and they can go?
Yeah, so I think we're still in the process of doing that right now. So we developed that feature within the last month, and so it's already been a little bit more idiot-proof than it was the first version.
Yeah.
But we're continuously working on that so that you would just be able to press a button, and then that's something that we'll be working on in the next few months.
Yeah, being able to have these just right up there.
Yeah.
The 2D version, do they have to be an exact, it's 5 meters apart?
No.
It can vary.
So we can triangulate among our radios to figure out where they are. So you just set them, forget them. We can get triangulation.
You have a tape measure to set
Nope.
No.
None of that. Yep.
It operates on what again? What frequency?
3.1.
3.1
Oh,
to 4.8 gigahertz. Sorry.
Yeah. No, you're good.
So I'm going to go in a little bit of a realm here. If I'm in a building and I blast a higher frequency and I raise the noise floor, what then would you see on the inside of that building?
Yeah.
Basically jammed from inside. If I jammed you from the inside
Yeah.
out,
Yeah.
would you see anything?
Yeah, so there's particular kinds of jamming that they'd be more susceptible to. I mean, these are pulsed ultra wideband, very low power. We can boost the power quite a bit, also make them a lot more directional. That's particularly one of the things SOCOM's interested in, getting that extremely directional. And that's one of the things we're working
Right,
towards.
the more directional, the less opportunity for jamming.
Yeah.
The more omnidirectional.
Yeah,
the
Yeah.
easier it
you
is to
can
jam.
do a number of processing to remove that jamming. Yeah.
You know, if you got rid of the power and everything else, how large is the actual sensor in there, or your whatever you're using?
Yeah, it's pretty small. It's like this big, and then you have some antennas. So, but if you removed power, you can see a lot further, and there's a lot less, I guess, constraints to the range and everything.
You can also consolidate that down to a chip.
Yeah.
Yeah.
So you said that 22 feet was the distance. What kind of resolution do you get at that
Yeah,
distance?
so 22 feet was actually so it's 49 feet now. 22 feet was what we had when we presented last time. And so resolution theoretical is about 4 centimeters or 2 centimeters.
Yeah.
So at 49 feet, you can tell it's a person, or
You're just kind of seeing right now
There's
just
something out
that there's a person out there moving. You're not getting any of that pose detection or anything, and so that's what we'll be working on in the future. Yeah.
But there are actually additional analysis you can do even on 1D to actually start to identify people versus other things.
So you say weapon detection. What style? What type of weapon? Are you people holding rifles or possible booby traps behind doors?
We'd rather talk about that one offline.
The competition that you said you're going to go to, the see-through wall test
Yeah.
bed, who's running that?
So it was RRTO. It was in September. Yeah.
And they had standard walls, some with concrete reinforced, some brick, some wooden.
Yeah, it was they had a rappel tower. They had a small area with like a siding structure. They had a thick concrete wall, a burn building. So there were about 5 stations, and there were 4 or 5 companies there doing through-wall sensing.
For your sensing, if someone goes out of range of either where you're looking or if you lose that, is there any sort of reference on the screen where there's an X or a ghosted out person?
Yeah, so actually that was a requested feature we got at Thunderstorm, and so we just put it on the product timeline map. It doesn't exist now, but it's going to happen in the next few months.
So if I have it in, say, a 2D mode, and one of the sensors goes down, does it default back to that one-dimensional, as I can spell, at each individual, or they lose sync, for example,
Oh.
they'll get 2 one-dimensional images?
Yeah, we're still collecting raw data back from the devices individually.
Okay.
So if you were to look at those device screens back there too, you would have saw 2 1D trackers telling you how far away each one was from the respective device.
Okay, so each individual will have a one-dimensional picture. Who
Yeah.
gets that two-dimensional picture then? Where's that picture?
Separate phone, yeah.
So we can pipe that back to anywhere, particularly the cloud for first responders. So that way, any and all the first responders can all get that same perspective.
And the intent with that too is to get us, we know that you don't want to stay near dangerous walls. And
Yeah.
so getting as far away as possible if you're going to be doing any surveillance is beneficial.
Can this be combined with any other type of radar modality to give you additional imagery? Whatever?
Yeah, so we're actually looking at using it with a number of other sensors. So that way we can use each to their best advantage.
Yeah, we can talk more about that too. Yeah.
From a production standpoint, once you guys get what you're comfortable with and the customers with a finalized design, do you guys have a plan to take that to larger scale production or mass production? Can you talk on that at all, or do you have any concerns? Or
Yeah.
Yeah.
Yeah, so we have a local manufacturing partner. We're based in Boise, Idaho, and so there's a manufacturer there that does military-grade devices that we've already talked to that can scale up to tens of thousands of units. They're also ITAR compliant, and it's really nice to work with a manufacturer so close to your office because you don't have to fly anywhere to go work with them. So we're confident we can do that. Yeah.
They manufacture devices for all the big primes.
And what are some of the physical limitations of the device? There's atmospherics, things like that. You know,
So the one big limitation is that radar waves don't penetrate metal. So that's, you have to see around it. Yeah.
So you mentioned earlier it just tracks a single person, okay, or detects, right? So what is the plan said to go forward to address that issue?
So we're currently actually doing multi-person tracking in our expert mode. Requires a little bit more finesse right now to be able to interpret that. But we'll be able to have that into our easy mode or radar mode within the next couple months.
Do you guys have a degraded mode in terms of if I put it against, say, a commercial wall with with metal studs? I mean, would you either see blind spots, or would the user get some sort of indication that, you know, hey, this is it, we have this degree of confidence, or here's our blind spot? Do you guys?
Yeah, so we don't have that right now, but our plan is to implement that, as well as if you're on a stud or something, eventually tell the user that they are on a stud and that they should move the device over.
Okay. And would that be a binary thing, or would you get kind of a degraded, you know, hey, there's a blind spot here, we're only at, you know, this degree of confidence?
If you were right on a stud, it would be pretty binary, just because
Sure.
it would be pretty obvious.
Okay.
Yeah.
But then with that, that actually goes into a lot of our dual purpose use cases, using in construction, a number of others for analyzing what's going on inside the wall. And that also really matters for explosive breaches. Not, I mean, you need to know, particularly in hostage rescue, like if you're going to shrapnel inward, how is that, where are the people, and how is that shrapnel going to go? If there's a stud there, or pipe, or something else that's going to complicate that.
you spoke to a little bit also about the hands-free operation using acoustic type cues and things
Yeah.
like that. Are you able to speak to a little bit more on how you plan to provide information to the user if they can't necessarily look at a screen or use their hands to
Yeah.
update maps, things like that?
Yeah, we can. We have a lot. We could talk a lot about that offline if we want to do that. Yeah.
Is that all for the?
Yeah. If you have
Sure.
more questions too, we can talk about some of that stuff now.
Yeah. Thank you.
Thank
everyone.
you.